Hey everyone, welcome back to another Ask Gen. This is the third one that we've shot in the last hour and a half. So go to, as always, the channel for the other episode. Post your questions in the comment section below. And also check out the Patreon bonus Ask Gen if you want some extra questions in there. And some of them are business questions, some are about like where to learn more about PC hardware in a technical sense. Those might be useful for some of you. Patreon.com/GamersNexus to grab that episode. This one we're going to be talking about third-party players in the market for GPUs and CPUs. So competition for Intel and AMD and NVIDIA, for example. Before that, this video is brought to you by Thermal Grizzly's high-end thermal paste and liquid metal. Thermal Grizzly's Cryonaut is an affordable, high-quality thermal compound that doesn't face some of the aging limitations of other pastes on the market. Cryonaut has a thermal conductivity of 12.5 watts per meter Kelvin, focuses on endurance, is easy to spread, and isn't electrically conductive, making it safe to use on GPU dies. Thermal Grizzly also makes Conductonaut liquid metal, which we've used to drop 20 degrees off some temperatures in our delidded tests. Buy a tube at the link in the description below. Quick note, just like I did in the other one, these shirts are finally back in stock. They were out of stock for a couple weeks. It's the teal version of our teardown logo shirt. We have them in cotton and in a very comfortable tri-blend if you prefer the sportier, lighter weight feel. So store.gamersnexus.net if you want to pick one up. They're in stock and shipping now. First question is from the Heartfelt Kid, who said, how long before you think we'll see a third party in the GPU and CPU market? Not necessarily an askgn question, but it is a great one. So the interesting thing here to me was that you're saying how long before. There have been third-party competitors in these markets ages ago, and they all died. So first thing I want to point out is anyone who's interested in the history of the industry, the hardware industry, I would really encourage you to look up SGI. Was it Silicon Graphics, I think? Silicon Graphics Incorporated, maybe was it? I don't remember the exact, but it was SGI is the point. And Jensen, the founder and CEO of NVIDIA, came from there. And SGI is a really interesting company because they more or less indirectly birthed NVIDIA, which later was a contributor to SGI dying. And so there were other parties at one point before NVIDIA and AMD and Intel. Not so much before Intel in a huge sense, but there were IBM. But so yeah, look up the history of SGI. It's really interesting. Some of the problems they had were like, SGI, for example, believes that consumer GPUs would just never be a thing. They just thought consumers would never want GPUs, they're too expensive, and really what do you need to do with them? So SGI was just dead set on making corporate grade graphics products and making stuff for companies and B2B and enterprise and stuff like that. And that was a huge misstep for them because out of that refusal to really push consumer and try and make it successful, even though it seemed too expensive. And it might, I mean, not just refusal, top management, yes, to some extent, but also on the engineering side, it was difficult to make them affordable. But that sort of disconnect with the interest of the market is why NVIDIA was so successful and ATI, to the extent that ATI was successful back before they were purchased by AMD. Other third-party players, you had Matrox at one point with 0% market share these days. You had VIA, which is theoretically they're doing something now from some of the stuff we've seen, but I don't know if it'll happen. IBM still makes their power CPUs, so IBM's not a competitor in x86. They're not a competitor, at least not in anything that we do with enthusiast desktop or consumer electronics. They just don't exist anymore. But IBM makes the power CPUs, which are in the brand new Summit supercomputer, which I think is the best supercomputer in the world right now. It just put the US back on the top. China was on top for, I think, several years, and the US just knocked it out, and that was with IBM Power CPUs. So there are other competitors. It's just not kind of in our space, but I know what you mean. Cyrix, by the way, I don't know if I said them or however you say their name, Cyrix. They were another one that's basically dead now. Voodoo Graphics made some of the best graphics cards. They were more or less killed as well by NVIDIA's dominance in the market. It's a tough market. It's really, so here's the problem. Getting to your question. You said how long before, so that's implying you think there might be some in the future, and that's great. I hope so too. So how long before? Things we know. We know Intel is working on a GPU actively. They hired Raja Koduri. He's the former chief architect and head of the Radeon Technologies group at AMD. He was largely responsible for He worked on Polaris, Vega, and I think Fiji. So Rajat Tori's at Intel now, heading up, or at least engineering, the Intel GPU. And that is, Intel's going for some pull in probably machine learning and deep learning, which is great because NVIDIA is largely dominating that market right now. Google's doing a lot of work in that market. It's a huge growing market. Gaming, by the way, is still like 60% though of NVIDIA's revenue. And I'm using NVIDIA as an example because they're huge. So 60%, 50 plus of their, more than half of the company's revenue in gaming, which means there's money in gaming. And Intel, as we understand it, is looking at potentially doing a consumer GPU. It's not 100% confirmed, I don't think. At least we don't know to like what sort of performance level we should expect. But they're looking at doing it, and Intel's been making integrated graphics for a while now. They've gotten better. They're still not great, but they're better than they were. I used to call it the Intel Graphics Decelerator, and I don't call it that anymore, though I still don't generally use it. So how long before? Intel, probably within the next several years. It takes a long time to make a GPU or a CPU. You're talking years of architecting. It could be 5 years, for all we know, before there's anything that's actually remotely competitive. And who knows if that's going to be enterprise or consumer, or if they'll even bring it to consumer in the first iteration. So that's a problem if you're looking at consumer. But the fact that Intel's even considering this is pretty big news. I'm not saying that like go Intel or anything like that. What I'm saying is it takes a company at about Intel's size with a market cap of what? Between, I don't know what it is anymore, but between 150 and 200 billion or something like that. Gigantic company, surpassed only recently by Samsung, I think, in silicon fabrication. Takes a company of their size to do this, because if you want to own the fabrication plants, you're talking multiple billions of dollars. Otherwise, you're working with Global Foundries and TSMC and companies like that who will do this silicon production for you, which is fine. They do a good job too, and NVIDIA and AMD both use them. But it takes big money, and those fabs, to get on their list, is also very expensive because you have to outbid everyone else to get your processors made. So to answer your question, with Intel, I think Intel's the first we're likely to see, if there are even any others. The industry kind of encourages, actually, our society in general sort of encourages things like duopolies when you're talking about these multi-billion-dollar investments to make a product. So I don't know that we're going to see a huge shift, but Intel might do something. Who knows? Maybe that means other things. We're seeing in China, for example, the Diana CPUs that we mentioned in our hardware news video. Those are getting made. It's a company that's 51% owned by AMD, so that they can get the x86 cross licensing over to them. So that's the other big thing. CPUs, to see competition in the CPU space, not only requires a ton of money and a ton of talent and a lot of time, which also requires money, but also requires licensing. So x86, basically what all modern gaming desktop computers are built on, is and there's a common misconception that x86 is like solely Windows 32-bit or something, but no, you need x86 processors to run anything that you're doing on Windows gaming and stuff like that. x86 is an Intel thing they license out. AMD has x64. They cross-license each other. It's a symbiotic agreement. But for both of those to be licensed to another company requires tricky things like 51% ownership by AMD, which, how much is it really a competitor at that point? So those are some of the things to consider. Intellectual property is a big hurdle. Money is a huge hurdle. Billions of dollars to make your own fabs, or otherwise just start engineering something that's competitive and then find a fab to make it. So yeah, stuff to think about. IBM Power is still out there though, and is useful in supercomputing at the very least. I'm sure there's other processors I'm overlooking. Post them below. Give people something to look at and research, but we kind of know what exists in the consumer market. I answered your question. The previous AskGN will air that otherwise. It was about NVMe SSDs, NVMe M.2 SSDs, excuse me. That was a really good question, though. I had it on here twice for some reason. But check the other AskGN for that. It's about heat sinks and whether or not they are BS for NVMe M.2 SSDs. TruckerNerd said, AskGN, save voltage for 24/7 OCs running an 8700K at 5.3 gigahertz all core with 1.35 volts. That is really good. That's like what we're doing on our 8086K. You must have gotten one of the good 87. Your 8700K would have been binned as an 8086K if they were binning them at the time that it was made. So Is anything below 1.42 safe for 3 to 5 years? I can't give you a year estimate, or is it better to run lower than max obtainable frequency in favor of lower voltage? So 1.35 is fine. I wouldn't worry about that. So even for long-term use, 24/7 use, don't worry about it. 5.3 at 1.35 is crazy. You got one of the best 8700Ks that's out there. It's a gold sample. If you wanted to run, I don't know, let's say you could do 5.2 at 1.25 volts. I'd probably do that just because it's a lot lower heat, it's a lot lower power consumption, and your gaming performance or even production performance is basically unchanged by 100 megahertz difference. So, yeah, I would not worry about 1.35. 1.42 plus is definitely kind of the barrier for comfort for long-term use. Be most careful about your SA, system agent voltage. Don't push that too high. Definitely not 1.4 volts, ideally 1.3 below. And then VSOC on AMD is a different story, but same idea for that one. Next question is from QuantumBraced, or actually statement. PCIe 4.0 will greatly help with M.2 SSD speeds and Thunderbolt eGPUs. This is in reference to the last AskGN where I talked about PCIe 4.0, and I was talking specifically about graphics, but QuantumBraced and 2 or 3 others of you who commented on this, and one of our friends at a company who contacted me, you all have a really good point, which is I did not talk about PCIe 4.0's or 5.0's usefulness for I/O. I didn't really think about it at the time. For graphics is what I was focused on. That all that stuff still applies if you have PCIe 4.0 questions for graphics. But for I/O, 4.0 makes a lot of sense because you can accomplish the same amount of throughput with half the lanes. So that's a great point. Thank you for pointing it out. If you have 2 times the throughput per lane, then yeah, for things like NVMe SSDs where you're already kind of potentially bumping up against 4-lane limitations on Gen 3, then it's going to help because suddenly 4 lanes will achieve the twice of what they did previously with 3.0. Another thing to consider is the PCH. So Intel, the PCH is connected via DMI, and that interface is 4 lanes as well. So with a newer PCIe, if they're going to stick to DMI the way it is now, if they keep going across PCIe, having a newer generation PCIe with more bandwidth or throughput potential there is going to be helpful for all attached I/O devices to the PCH. So great point. Thank you for pointing it out. Next one, jathbrisk says, this may seem like a silly question, but is it super unusual to be able to overclock the memory on a GTX 1080 to 1000 megahertz offset in Afterburner? My friend just bought an MSI Gaming X 1080 this weekend, and I helped him OC it. Got around plus 150 on the core clock. I was pretty astounded by the results. Runs totally stable at that OC. I have seen it before. A lot of the time, it's sort of tricking you. So one of the things to consider, this is something that was taught to me during the mining stuff. So when all the mining craze was going on, some of you, I think, did some GPU mining and commented about some of the things that I said in other videos. And one of the things I learned was that mining, because I guess it's pretty memory intensive, you can get these plus 1000 offsets to the GPU memory, but in reality, if you check the hash rate, I guess, you'll see that there are a lot of invalid hashes or something to that effect, because it'll look like plus 1000, but it's actually either encountering memory errors or just inaccuracies, or is unstable, but it looks stable. So plus 1000, depending on the application, is potentially a misnomer or misleading. It might be throwing memory errors. You might not see it reflected in games, but it depends on what you're doing. So to answer the question, it is unusual to actually do that kind of memory overclock with legitimacy, like actually stable, unless you're maybe using like binned down memory that was supposed to be 9 gigabits per second, but they just called it 8 because they needed to fill market demand or something to that extent. So it's pretty unusual, yes. Whether or not it's actually stable is the bigger question. So you might want to find some GPU memory benchmarks, run it through them, and just see if it throws any memory errors. And also check and see, look at GPU-Z and cross-reference it with Afterburner, and cross-reference that with UGA Precision. So use 2 tools for the overclock. See if you can get the same offset, and see if 1000 in Afterburner and Precision give you the same numbers in GPU-Z. Because if they don't, sometimes I've had things, and I don't know if this is happening here, it depends on what version you're using, but I've had issues with Afterburner in the past and Precision where it'll interpret some of the inputs, it'll accept the input, but the output will actually not correspond with the input that I typed, meaning that you'd be able to type in a higher number than was reality. So you can use those applications to cross-check. Next one is from, and you'll typically see reduced performance or stutters if it is unstable, so it sounds like you're not seeing those though. But that's another good one to look for. Next one, I'll be Frank I'm Leary about using my name. Says, is 3200 megahertz CAS 14 still the sweet spot for DDR4 RAM? Or to state it differently, does the looser timing of, say, 3866 CAS 18 negate most of the speed benefits, leaving me with more expensive RAM for no noticeable improvement? Our live stream with the 8086K spent like 2 hours doing memory stuff. It's easy to get diminishing returns with RAM. Let's just assume you're running something that can actually do 3200 and 3800 plus, because that's the bigger thing. Can the IMC do it? Can the motherboard do it? Can the architecture support it? So let's assume that those are all supported. In that scenario, running something like CL14 3200, I would say is definitely a sweet spot, in the very least, for affordability. 3200 CL14 is pretty affordable and highly performant. We'll use that made-up word. Whereas 3600, if you can afford it, is more of the real sweet spot, because if you can do 3600 at CL16 or 14, depending on the quality of the die, then that's really where you kind of cap out, and at that point you're diminishing returns territory for a lot of architectures with any kind of workloads that we benchmark. There are things I'm sure that would do more with higher speeds or something. As far as frequency versus timings, yes, some applications, Firestrike's a great example. If you run CL11 or 12 on Firestrike with slower frequencies, it's going to get you a lot further than if you're on a higher frequency with CL14 or 16. So yes, there are diminishing returns. The point I would say where you encounter those is going to be like 3600 or thereabouts, or 3400, somewhere in that territory. You kind of get a black hole in there, some between 32 and 36. But stuff to think about. Next one is from Solarity, who says, do stator vanes increase static pressure on fans? If so, why don't more companies use them? I'm going to keep this short, but I asked Noctua about this at Computex. So stator vanes, the idea here is that you're putting a guide between the radiator and the fan, and the idea there is that it distances the fan hub from the radiator. So the fan hub is kind of a dead zone. If you put a fan right up against something you want to cool, the middle of the fan's not going to do anything, and so whatever's behind the middle of the fan won't get cooled. So the idea of a stator vane is that you're creating a gap so that the air has some chance to sort of form around the hub and cover the whole surface area of fins rather than have a dead spot. Talking to Noctua and others about this, I think, and Noctua said, actually spoke with another company as well, but one of the three companies I spoke to said they've looked into it, and that oftentimes the radiators have enough of a bump, like a gap between the radiator housing and the fins, that they don't need a vane in there separately to allow more airflow. So that's something we might test in the future. I've considered it. If there's interest, I'll look into it. Super behind right now. No promises on a timeline. But from what the companies that have looked into it have told me, it's just that there's kind of a point of diminishing returns. You really increase how fat that whole radiator fan combo is, which is a big problem for usability. And I guess the gains were not worth that usability hit. And I guess from what I understand, some of the better radiators that space the fans a bit farther from the fins do fine anyway. Great question though. Something I'm also curious about. Last one. RC asks, how do you define a gaming router? In quotes, do they actually offer benefits, or are they basically just gimmicks made to entice people into buying a fancy looking router that basically does the same job as regular router? I define a gaming router as 99% utter BS. That is my definition of a gaming router. They might have some extra features. Honestly, a lot of the time it's just tacking the word, just like with gaming chairs, tacking the word gaming on it to hit a target market that might not know a whole lot about the component, and they just know they're using it for gaming. So, damn it, that thing's called gaming router. It probably will do what I want. It might have a better interface. You don't really need to port forward games anymore, but maybe that's made easier. Some of the ones that I've worked on in the past, and we don't do much with them, really have like zero feature difference at all. They just look like a fortress or something instead of a router. Personally speaking, I prefer to buy more office-focused things for office tasks like high-speed internet, even if I'm using it for gaming, just because I'm going to trust that I'm not overpaying for the word game in the title of it. So no, they don't offer a ton of features that are actually going to be legitimately useful to you. They might have some things, but I question whether those things they have are anything you can't do on your own with a normal router. So that's it for this one. As always, go to patreon.com/gamersnexus to get the bonus episode. Go to the channel and subscribe to catch the other AskGN episode. Might already be up, I don't know, plus or minus 18 hours on that one. Subscribe for more. Store.gamersnexus.net to pick up this restocked teal teardown shirt. And thanks for watching. I'll see you all next time.